everything is being decoded. Everything is being decoded at KFS on all channels. What's funny is that I'm using the very same antenna they're using because that's where these messages
Yes.
are recorded or received when they're sent to San Francisco. And I'm sharing the same antenna with them. Anyway, this is a packet radio scheme that airplanes use over the water um, to well, it's sort of like it's a little bit like ADSB, although it's a different system, but it works on HF, and they
Oh,
can
I
also
see.
send ARINC, text messages and other things. But what's interesting, I think, for us and for the ham people, is all the overhead, all the HF connectivity stuff that we could glean things from.
Yes.
For example, okay, I scroll back here. Here's a plane AVA 931 at location 6 degrees north, 75 degrees west. Um, this is saying all the frequencies it's listening to and which ones it has heard the base station on. So that tells you, not only that there is propagation there, it also where there isn't propagation. Although I guess most whisper beacons are on all the time, so you can pretty much count on that if you have a negative report. Um, oh, there's a piece of a text message. Um, but yeah, these planes are sending these overhead messages all the time. And so I thought they might be useful for propagation
For
research.
propagation, yes.
Yeah. Here's a typical uplink. This one's coming from Thailand, and it's listing the frequencies that it's currently working on. And also, it'll give the frequencies for two other ground stations in the network, and it rotates them so that all you have to do is get one of these. And then if you wait a while, you'll figure out all the frequencies that are currently active. Although I make that, I listen on all of them. So who cares? You don't have to scan.
That's right.
Here's a summary request from this particular airplane, QTR-99Y. This is over that's over the continental United States somewhere, I think. Transmitting to Riverhead, New York, which is on Long Island. And it's its summary of messages as it received, what speeds and which ones were received with errors and without, how many it transmitted. So again, you
Very
can
good.
infer some interesting propagation stuff from this.
Yes.
Frequency is right here, 66, 61 kilohertz. Is received with a Doppler shift of minus 2.1 hertz. Signal noise ratio. I think this must be the input level to the demodulator during the signal and during noise, which because these sound about right for being the signal noise
Yes.
ratio. And then you have the data rate of the message. It can be 300, 600, or 1200. I think 1800, though. I've never seen that. 300 is the most common. So, yeah, more, looks like a weather,
Looks like a
yeah,
message.
looks like a weather forecast
Yeah.
from Hawaii going up to a particular plane. More of these, it seems like this network is almost nothing but overhead. It's so much of it has to do with HF connectivity. They figured,
Yes.
well, we might as well use it.
And the fact that a plane is involved, it's way up in the sky. So it, it makes it interesting.
Well, what's even more interesting is it's moving
And it's moving.
and it's
Yes.
over places where hams often aren't, like the
Yes.
water.
The
I mean,
water.
that's where they're using HF. It's over oceans. Although actually, I see a fair number of these over the United States. It's surprising.
Yes.
I guess they must leave it on sometimes for flights over the U.S., but often like over northern Canada, over the water. And of course, they're moving. So, it's a moving propagation probe.
Well, I run a ADSB receiver here.
Yeah, I did until my antenna blew over. I just haven't gotten around to putting it
Yeah.
back up. because
And
other people or else
but
other
it's
people are doing it.
interesting that a lot of these planes, once they leave, they go up towards Alaska, but then there's a big chunk of the Atlantic that you don't see anything,
I think there's now
or
satellite
the
coverage via
Pacific.
DSB.
Yeah,
If you look at Flight Aware, Flight Radar, you'll
yeah,
see a lot of stuff over it. I think it did say it was by satellite. I mean, that was an obvious thing to do.
yes,
Um, oh, here's Guam. Again, a Guam from KAL, Korean Airlines 081, somewhere over the Western Pacific here.
yeah,
Well, yeah, Guam. Um, as I said, each station transmits periodically which frequencies it's active on, and then, here we go. Here's Hawaii advertising that it's on these three frequencies, and at the moment, San Francisco, California is using these two, and Reykjavik, Iceland is using these three. So, I can also just infer propagation between the ground stations, by which ones I happen to hear here.
that's
Uh,
right.
there are some I don't think I've ever heard, even with KFS's antennas.
Yes,
I don't think I've ever heard Barrow, Alaska, probably because HF just doesn't go well over the poles.
yes, I understand that,
Yeah.
especially in these frequencies.
Yeah. Well, the lowest frequency is actually around 3 megahertz.
Yes,
I don't see it in this list right. Here we go, two nine
there's
eight six.
29.
Yeah, and the highest, yeah, almost 22 megahertz.
Very,
Um, these are these are the HF aeronautical bands. They share the same bands with sideband,
right.
and each of these stations has. I've been there. Rob showed me the site, and I saw a bunch of big racks full of these Ten-Tech rack mount HF receivers, and I looked them up, and each one lists for like $6,200. I could replace them all with
Yes,
RX 888 and medium PC.
yes.
And I don't even know whether this system, whether they have multiple receivers, whether they receive more than the just the frequencies that site's using over as the San Francisco. I don't know whether they listen on other base stations' frequencies or whether they only listen to their own.
Well, the
Probably.
aviation people may or may not, but I bet you somebody's listening.
In the rack, I mean, I could see equipment that was the labels implied that it was part of this network, this
Yeah,
is what it received. But the labels weren't very descriptive. Some of the radios had HF sideband frequencies written on a piece of tape on front, so it's obvious that those are fixed. But
yeah,
they also had a bunch of what appeared to be spares, and they can be remotely tuned. So I don't know whether they ever put those spares into action receiving other frequencies. But here, you could have every station listening on everybody's frequency so that
right.
anybody in the world hears you, the network will hear you,
Yes.
even if only one ground station transmits back.
Have you put the config file for the way you've got it now
Oh
for
yeah, I,
your?
I I just did a couple of Git pushes this afternoon.
Okay,
You also have to install the dump HFDL package separately,
okay,
which I don't think is an apt package. You do have to pull that down and build it, but I can help somebody with that. It requires another library for ACARS messages. It also has to be built from a repository, but it wasn't that hard once I figured out how to do it. Um, see, I can show you what the config file looks like. Yeah, there's not much to it really. Um, then service file. It makes use of my new PCM record.
yes,
I put it in for this sort of thing. So it starts up one copy PCM record with the raw and exec options. so that every time a new stream is seen on this particular multicast channel, it invokes a separate copy of the HFDL decoder and then pipes the received audio into its standard input. And then the rest of these arguments are arguments to the dump program. So it's putting its output into a log, which we're just seeing, reading its IQ from the input. And then I added some macros yesterday so that these get expanded to by PCM recorders. So this $R
Okay.
gets expanded. The sample rate, the center frequency in kilohertz, the sample format is fixed at 16 bits, and then system table, and then the frequency in kilohertz. So let's see there, 5 HFDL. Uh, that's the configuration table. That's actually distributed with the software. But if a
Okay.
new one is sent over the air, this will automatically receive it and update the file.
Oh, okay.
So you can see these are the frequencies that all the frequencies that San Francisco could use. And any given
Yes.
instant, they're only using two or three. Some of them do overlap. I mean, there are some frequencies that are used by more than one station, but never at the same time that I've seen. Now, this one's interesting. This is in the 75 meter ham band.
Yes.
I know that they don't have the hams don't have that section in Europe, but I didn't know. I thought it was only used for broadcasting. I guess it's not just broadcasting.
Yes. Interesting.
And this one's just below 80 meters. Um,
And those two stations are close, relatively close.
which ones?
Uh, you had Reykjavik and the other one was Shannon,
Oh, Shannon, Ireland. Yeah,
Ireland.
yeah, Reykjavik.
Uh,
Shan
for airports, that's not too far apart.
well, for HF is not too far apart now.
Yes.
Vero, Alaska, they have a long list here. I guess they probably need the most frequency options.
And you have them coming from all directions.
Well, also in the polar regions, HF propagation is pretty sucky. So I guess they need to
Yes.
be able to be agile. Uh, there's one in Russia, as far as I know, it's still active.
I did see one from Russia
Yeah, there's
somewhere.
one. Where is it?
There it is. Right
Oh,
near
there
your
it is.
cursor.
Krasnoyarsk. Yeah, it's like in the center of Asiatic Russia.
Yeah.
I don't think I've ever heard it, but I can look.
Some years ago, I flew to China in the 2000. It was 2006, and the flight took off from Chicago and went straight north and went over the
Yeah,
pole and down over Russia. And they don't do that anymore.
they don't do that now. No, not as long as the war's going on.
So,
Well, it saved a lot of fuel and probably made a lot of money for the Russians too. After the
yep,
Cold War ended, to fly airplanes over Russia.
yeah,
I mean, it's so big, right? It's kind of hard to avoid in any kind of. Uh,
yeah. I notice watching ADSB that a lot of stuff gets filtered in very narrow channels now, or zones where the planes fly.
well, yeah, sure, air routes, sure. That's
Yep.
that's always been true. Um, Even over international airspace, they have defined airways, and they have spacing is greater because they're not being tracked by radar
Yes.
typically. So I read up on the modem that this thing uses. It's a single tone modem. It's similar to the mill standard. Um, what is it? 188 modems, I think. It uses PSK, either
Oh,
binary, quad, or eight phase QPSK with at a symbol rate of 1,800 symbols per second, which is pretty high. So it requires equalization.
Uh,
And I haven't looked at this code to see how much of that is done, but it seems to work well enough. It probably does have an equalizer in it. But I also found a paper published in 1999 arguing that that was definitely inferior to an OFDM modulation that they also tested. That paper
uh,
was written in 1999, so this is not a new system.
no, it isn't.
Yeah, but it's still being used.
But it is interesting that you get all this metadata on
Yeah, yeah,
each transmission, actually, isn't it?
pretty much each transmission. Yeah, yeah. I mean, small fraction of it is not metadata.
Yes.
Yeah, it's a fair amount of buffering all over the place, which is why all these come out in big bursts like this. And I'm trying to get Rob to redo a lot of Whisper Daemon around this program. I think it'll simplify things for him a lot.
Yes.
Certainly simplify configuration. The only place I had to do any configuring uh, for all the channels was in the radio D configuration file where I have a list of the frequencies
Okay.
all going to one special multicast group. And
Oh,
then
okay.
whenever PCM record sees one of the streams appear on that multicast group, it automatically launches a copy of HFDL with the right arguments to receive that group. So you don't have to have anything to actually configure and launch the decoders.
Oh, okay. That sounds good.
It's all done by PCM record with those arguments inserted. Oh, anybody else is showing up. Dave's
Well,
here.
Dave McGaw's there. I don't know if he's got it mic turned off, but
You did join.
hello, David. And then Scott is there with both channels, so
Yeah,
presumably he can talk on one of them.
yeah,
Yeah,
yeah.
I can
Got
talk.
Okay.
Hey,
good. So
It's a
I was
kind of an
hoping to make some.
interesting for interface.
Yeah. Now I can figure what to do with all this data. I wish Nathaniel was here because I mentioned
No,
to him months ago that I was looking at
yes.
doing this. And I
Well,
asked him if he thought it might be useful. And he said, yeah. But so now that I have it, I want to ask him, okay, what do I do with it?
so he's going to be off tonight and then next Monday night
Okay.
because he's just having Christmas with his family.
Oh, I understand. Yeah.
And
Well, please.
he he told me ahead of time, but he did. So Zoom did some changing to their interface, and I had to figure out how to. I wanted to record and put it on Nathaniel's machine. So we are right now recording,
Yeah, I saw that.
and it will go to his machine so that he can post these.
Oh,
Uh,
okay. So you can see what I just
yes,
said.
yes. So, and
Uh,
lots of people that don't show up on a regular basis actually go and watch the recordings to
okay.
see what's going on.
Well, if any of the scientific types have any ideas on what should be extracted from this, have at it. Well, I mean,
Yes.
they could let me know, but look, I don't have to do all the work.
No.
Here's the software. Go write your own scripts to extract
Yes.
whatever you think is useful here.
So, and I'm trying to do some stuff through Tapper to encourage the use of K9Q radio and
Oh, good.
explain how to set different things up, not just the standard whisper stuff, but
Yeah.
because I want people to realize there's a whole lot more to it.
Well, and it's changing like this
Yes,
right now. Yeah, I didn't when I
but
just did
there are
this.
parts like the APRS is pretty stable, and uh, now there's plenty to do there, but still,
Yeah.
you that's probably the part of the most mature part of the program
I
at
wonder
this
how
point.
stable these transmitter frequencies are. They're all within a few hertz, and that's probably Doppler.
Yeah.
Probably not enough for scientific measurement of Doppler, though. But it has to do a precise uh, frequency determination during the modulation. So the number
Yeah.
here is pretty accurate. Oh, there's Clint.
Oh, yes.
Hey, Clint. As you can see, I got HFDL running on all channels at KFS. Now I got to figure out what to do with it. At the very least, it ought to be possible to extract the data and send it over to flight aware and flight radar,
Right.
the tracking data.
Well, for the recording, I will say that Clint K7EOEI, David McGaw N1HAC, Scott Newell N5TNL, myself, Dave Larson, KV0S, and Phil Karn, K9Q, are present. Any comments by anybody?
Well, I'm trying to set up for SAQ tonight, so that's my big project. And
Oh,
I've made no progress on the web or anything else this week due to work and family. But I did hear back from Infineon through my sales contact at Future, and it's not good news. So,
oh, the
yeah,
Infineon chip.
yes. The email said these parts are to be released in February. So I'm working on an early version of the DS. It's
Oh,
available, but currently under NDA access. So I'm seeing what we have with your company at this point and how soon we'll be able to share it without the NDA.
okay.
So pretty
Well,
much blew me off.
that's sort of what Dave Witten was telling me as well.
This was from Mike Anderson, but I don't have
Yeah,
his email. I got the message, but I didn't get the email header,
yeah.
so I can't bug him directly. But I'll follow up in a few weeks and again in February.
Okay. Well, he knew that apparently one of their big markets is cameras and photography. So um, they seem to, and I would assume that would probably be more lucrative than a bunch of ham radio guys.
Anything
So
is more lucrative than a bunch of ham radio guys.
yeah, well, we're not just a bunch of ham radio guys. We're looking at putting out multiple systems for scientific research.
Yes. Well, what's amazing is the diversity of backgrounds of the people that show up for things like this.
Yeah, and
Yeah,
look at how many
fun.
RX-888s are using
Yeah.
chips. Now, who's making what is Infineon making that we're interested in?
The FX.
Oh,
Well,
the
we were
FX10?
the 5 and the 10.
Yeah.
It looks like they're gonna just
Oh, I
jump
thought,
over the
okay.
5 and go to 10. But and what?
I can't keep straight who's making what these days.
So Scott was saying that they're by agreement available, and that's usually people
Right.
who have money, not
Didn't
just
they used to
purchasing
call
one.
themselves Cypress?
Yes.
Okay. Just to keep that thing straight. Mind if we call you Bruce just to keep things clear?
Little Python routine in Australia.
Yeah.
Yeah, pardon me for just listening for a while, but I was actually putting up a Christmas tree.
Oh, okay.
But very interesting discussion
Well, I
about
was
air
surprised
transmissions.
I didn't hear from you because typically you're one of the people that speaks up.
Right.
So
Well, Phil was doing a pretty good job of
yes. Well, Phil is
narrating.
he's playing with his new toy.
Yeah.
And yeah,
Yeah, so
I'm
yeah, it
looking
is a
forward
good
to getting
question.
this working.
How well controlled are their frequencies? How
Well,
can we
you
trust
take
the
a look. I
Doppler
mean,
shifts?
each each message it has a Doppler right there, see? Minus 3.9, minus 2.9.
Right. Well, that's an offset. We don't know if
Yeah.
that's
So
Doppler
yeah, we
or
don't know how well controlled the air oscillator on the
right.
aircraft is. Sure. I mean, they're close. They're well within spec. I looked up the spec. I think they require it to be like 70 hertz or something. So obviously well within that.
But it would be worth examining just to see how how much information could be extracted from this is
Yeah.
in propagation wise.
Because they are moving and they're over a lot of places that hams aren't.
So, Phil, what is this service called again?
HFDL, a pretty generic
Oh,
term,
okay.
high frequency data link. It shares the it operates on the HF aeronautical bands shared with single sideband voice
Uh,
and weather and stuff like that. It's been around for a long time, since at least the 90s. So it's not a new technology.
that they have been getting it from the Malaysian aircraft that disappeared.
Yeah.
I'm surprised they
Well,
didn't
I think
have
it was turned
location
off.
info.
I think the thing is that almost all that stuff was turned off except for that Inmarsat terminal.
Right. You mean
It's starting to look like
the
that.
telemetry the engines were sending?
Yeah. No, well, it was I think that was turned off too, but I
Well, they
wanted to
were
give that
listening to
guy
the
a
engines.
I wanted to give
That's the
that
one
guy a
thing.
benefit of a doubt. I didn't want to accuse him of deliberately crashing the plane unless there was real evidence, but it's starting to look that way.
More likely something catastrophic.
Well, my first thought was, how about a cockpit fire? It drove the crew out of the cockpit,
Right.
but then it sounds like some things were deliberately turned off. So, but hey, it's been what, 10 years now. We still don't know.
Yeah.
Yeah, I heard there's a new initiative to find the plane, and it's a no find, no pay. It's like,
Oh, well,
why would anyone take that?
really?
Yeah.
They must have a pretty good, it must be pretty confident in their abilities if they
Yeah.
would do that. I
Yeah,
wonder
the one
whether
interesting thing about it is they have found parts of it.
well, yeah, stuff that
But
floated
they
up and
floated,
around.
yeah,
So,
they've been all over the
well, they know it
Indian
crashed, right?
Ocean.
Because pieces of it did
Right,
wash. I can't remember
exactly.
Union Island, which is a long way from the site.
Right.
And there was really no way you could say, backtrack where that came from.
Actually, I should have asked the Polynesians. They could They navigate by the waves, and it's just incredible. You know,
Well,
it's all Fourier transform to them. They can tell where the waves are coming from thousands of miles away.
well, there is a network
Supposedly.
of free floating buoys, several thousand of them out there that are tracking
Yeah.
ocean currents.
True.
The one that Randy and I built is just one of thousands. So I don't feel too bad about adding to the ocean pollution.
I looked up a Rockwell Collins data sheet on one of these HFDL aircraft transmitters. They're claiming 20 hertz with an OCXO. So not GPS locked, but you know,
Yeah.
an oven, better than nothing.
Yeah. Well, they're obviously well within that, as you can see.
Yeah, but I wouldn't expect that we could actually call it a Doppler
Yeah.
shift. Just
I
an
mean, a
offset.
good fraction of this probably is the actual Doppler due to its velocity. I mean, it is HF, but they're also moving pretty fast. They'd have to work out the relative velocity to the ground station. Of course, that assumes a great circle route, which is not necessarily the case on HF. Curious seems to roll low. Well, actually, the sun is setting over the Pacific right now. Maybe that is
Right.
a real number. No, the Dopplers are negative. You see that? On the other hand, uplink SPDU, that's coming from its own transmitter that's 10 hertz low.
Oh, yeah.
Yeah. The signals are actually not that strong. The transmitter for that site is in Davis, California. It's the old VOA site. And it's surprisingly not that strong, even though it's paired with the receiving antenna that I'm using, which is in Half Moon Bay right on the coast.
Whoa.
Oh, I had stopped. I was
Oh,
looking
you'd
at some entries.
held it there. Okay.
Yeah, I held it there and then I just scroll back down to the bottom. Anyway, I wonder how big my log is getting. I had to have log rotation turned on. Let's see, how big is my log? Yeah, it's getting big.
How long has that been running?
Since last night,
Okay.
52 meg. Yeah, probably about right. But I included a log rotate config file, so it will
Oh, okay.
automatically get rotated along with FT8 and FT4 logs. That seems to be working fine.
Yeah.
I'm figuring their Doppler shift due to if they're flying at say 500 miles an hour,
Yeah,
Doppler shift would be about 7 times 10 to the minus seventh. So
minus 7. Absolute.
that's the absolute shift.
Okay, so
Proportional
at 10
shift.
megahertz, that would be 7 hertz.
Correct.
Yeah. Well, it's in that range.
In that range.
Yeah. Well, I wouldn't think that even an OCXO could be that accurate for a long period of time on an airplane. Temperature variations, vibration.
And just aging will
Yeah.
run it
And,
off.
and no real need to be any better either.
Right.
The file you're showing now, is this a FT8 or a 4?
That was FT8.
Okay.
So, okay, that's, yeah, there's a rotated file. So, oh, yesterday's file was pretty big, 30 megabytes.
Yeah. And then the red ones have been rotated?
Well, no, all of them have been rotated except the
Oh,
one
okay.
on the top. The red ones have been compressed.
Oh, compressed.
It
I see.
rotates every
Oh,
day, and
okay.
then it compresses everything when it's 2 days old.
Okay.
Thing. These files compress really well.
Oh, they do.
A lot of the strings are the same. So,
And a lot of white space.
yeah, not a whole lot of FT4 activity. There's some, as you can see, not like FT8.
Now, those beacons of Paul's, aren't they FT4?
I thought they're Whisper.
Well, they're Whisper, but
Um,
I don't know.
well, you want to see Paul?
By the way, what time is the SAQ transmission tonight?
The what transmission?
SAQ, the BLF station.
Scott was talking
Oh,
about it.
Scott was talking about it.
8 UTC, so 2 a.m. local my time.
8 UTC. Uh,
well, there's Paul
Yeah.
on
3 a.m. my time.
on Whisper.
Oh, and
Obviously
Whisper.
heard well.
Because I was thinking those transmitters were. Anyway, I'm
Not being heard on every band.
no.
You don't hear them on 10 meters.
And we're still
Close.
getting Michael's. So the transmitter that Paul sent to Michael or Rob sent to Michael is still on. As of today, it was.
What's it called?
AA8K. And
Yeah.
that's the one, Michael's deceased. So
Yeah. Yeah.
we're trying to find the people that have some control over turning it off and maybe even returning the box.
Yeah. Maybe putting in another site.
Yes.
Okay. Let's see. See about this one. Oh, hadn't heard from it. I hope it's still working. Oh, wait a minute.
You mistype it or something?
Huh?
Is the call sign?
KQ6RS. It's Randy's. Thank you. So a
Okay.
friend of mine. We built those buoys, and we've had one out there for a year
Yeah.
now.
I watched some stuff you put out earlier on that.
Maybe I should try the Southwest antenna. Yeah, we'll play. Because it hasn't been picked up by very many stations. Randy himself has been getting it from home, but he's got a hex beam that he usually uses in that
Oh,
direction. What is he running this on all antennas? I assume he is. Huh. Oh, yeah, okay. It's being heard. It was heard just a couple of times on the Southwest antenna. There we go. But that wasn't that recent. 12/21, 12/15. It's getting pretty weak. Well, I guess it's pretty far away too. I mean, I keep joking with Brandy that I want it to wash up on the beach at Bikini Atoll. It's sort of heading in that direction. I think it's probably being heard better in that part of the world than here.
yes.
That's the southwest antenna. One thing I've been very disappointed with is DRM.
Oh,
Clint commented a couple weeks ago that you really have to be in the service area to get DRM. I assume it's because of all the multipath. I've been getting very strong signals at night from KSS's QESDR, looking at the North Korean DRM transmitter on 6140. I mean, I see signal edge ratios of 18 or 19 dB. I see what look like very good constellations, but it still doesn't decode. I don't know why. I mean, if the multipath are bad, I would expect the constellations to look bad.
but it,
I
well,
don't know that that transmitter is intended for public consumption. No, the North Koreans are not saying why it's there, but one theory is it's being used to feed a bunch of local FM transmitters around the country. But I still don't see why they would want to encrypt it or anything. Probably
well,
can't
you never know.
probably can't see it yet. It's probably too early. Oh, rain for Scott. Lucky you.
Yeah, we got 2 waves of snow on top of a white ground now, so we definitely are getting a white Christmas here.
I'd love to have some rain here just to clean off some power line insulators.
Oh,
17.2 kilohertz. I do not have an antenna that can work there, nor have I done all of the work required to clean up.
I will mention that Michael Howen got the antenna that Glenn invented up.
Yeah.
And I have seen a pan adapter view of it. So it generally is really nice. He's still getting, when I was looking at it, it had some bouncing in it, but other than that, it it was fairly level all the way across
Oh, cool.
the band. And if you can figure out what the is causing the bouncing, which I assume it's some sort of short in the line or something. The whole pan adapter was bouncing up and down, not just individual signals.
Hmm. Is that KNIQ radio?
He's yes.
Yeah, I have that problem. I guess I need to talk to Glenn about this, about how I do averaging. Um, because my original approach is not working well.
Okay.
Well, I made some assumptions that have been overtaken by events and how I designed it.
Okay.
So let's see, SAQ, 17.2 kilohertz CW, 200 kilowatt Alex Anderson alternator. That's a CW transmitter? Sounds like Spark. What is that thing?
My understanding is like a overgrown car alternator.
Um, oh, I mean, it's just directly, okay, I guess it could directly generate 17 point kilohertz. It wouldn't be that hard.
Yeah, that's what it
Yeah,
is.
here we go.
Got lots of little tiny poles.
I found it. Yeah, in fact, there's a picture of it right here in Wikipedia. It's the same alternator. The only remaining example of an Alex Anderson transmitter. 200 kilowatts, invented 1904, 120 years ago. Wow.
Yeah, I think there is one still. It's not being used. Towers are all gone and everything, but
generator is at Sandestrom in Greenland, where I used to work.
Yeah.
And there's this big generator building. They call it the powerhouse, and it probably powered stuff around it, but it was also a VLF transmitter. But I know I found a listing for it some years ago, but it's been purged from the system, it seems now. So I don't know what frequency it was on. But yeah, this is just a very, very high frequency alternator.
Boy, that must have been tough. Generating that much power and getting over the inductances of something that big.
Yeah. Well, the site that Scott just posted gives a lot of information about it. So yeah, they turn it on sometime beforehand. They have to get it up to speed. Get the governor to bring it up to 17.2 kilohertz, and then they key the transmitter.
Yeah.
They've got a big dummy load that they dump it into when it's not connected to the antenna, so it doesn't change the speed of it.
Oh, yeah, I can imagine throwing a load on or off at that power level would be, yeah.
Yeah, I've tried hearing it many times now from here in New Hampshire, and I suppose to have enough of a loop to pick it up, but I've not seen it. I see the Navy transmitters all the way out to Washington State and down to Puerto Rico, and I can see some in Europe. But this guy is a little bit lower power, and I figure maybe I'm just on a node, because those happen where it just doesn't propagate to a certain point.
Yeah.
I know NAA has we're actually pretty close to a node for NAA, the 24 kilohertz coming out of Maine.
When you say node, what do you mean? It's standing wave in the Earth
Yeah,
atmosphere
I
waveguide?
mean it's a point of anomalous propagation or lack thereof.
So I guess this is why the Navy has multiple transmitters and multiple frequencies.
Right. But yeah, in terms of propagation research, we're actually at a pretty good spot for NAA because it varies a lot.
Yeah. Oh.
But that's, of course, a loud signal. Otherwise, it's like 2 megawatts coming from maybe a couple 100 miles away.
Yeah. I wonder if their radiation efficiency is.
Pretty low.
Yeah, I think even a huge antenna that.
They've got the antenna pretty much takes up a whole peninsula. And it's, of course, the great extent of it is just a big capacitor. It's the
Right.
vertical wire that's doing the actual
Right.
radiation.
Right.
Oh, I see.
Capacitors are the top hat to make it
It's
at
the
least
top hat, right?
Yes.
somewhat resonant, I guess.
Yeah, of course, WWVB is a miniature version of that.
Right. Well, they're also a little higher, somewhat more manageable. Not much, but
Not by much, but yeah, I mean, it's a top hat loaded
right.
vertical. Two of them to actually. Definitely getting a better signal now that they repaired the south antenna.
I haven't really gone for it. So there's just so much switching power supply noise here. Much of it comes
Well,
from my main Linux server, which I kind of need. The frequency in hertz and the wavelength in meters for this site are almost the same. 17.2 kilohertz and 17,400 some meters. Oh, well, nobody else is showing up, huh?
Oh, Nathaniel didn't
well,
show up.
no,
Jonathan
I
showed up.
wonder if
I mean,
that's how they.
Jonathan. I'm sorry.
I wonder if it's how they pick the frequency. It is the square root of the speed of light.
Pretty close, yeah. Yeah, it's probably as high as you can
That's
get from reading an article about these alternators. I mean, they were trying to get as high as they could go, but none of them were able to break 20 kilohertz.
right.
Wonder what it sounds like around there. When I was working in broadcasting in college, I could actually hear horizontal flyback whine from a room
Yeah,
full of, control room full of those things. And but that was only like the first summer. The next summer, I couldn't hear it anymore. I think I probably went to a couple rock concerts in between.
yeah. There were certain sets. The flyback transformer would its ferrite would get loose and it would make a terrible whine.
Yeah. I don't know whether there's anything wrong with these things, but this control room I worked in probably had, oh, I don't know, 40 or 50 monitors at least.
Right. And you're talking television broadcast.
Television broadcasting, yeah.
Yeah. Yeah.
Maryland Center for Public Broadcasting in Baltimore.
Yeah. At least with CRT monitors, they got the flyback horizontal frequency up beyond what we would hear.
Normally, for anybody out of their teens, anyway.
Right. Well, I used to hear it quite well. My hearing's not too bad, but the
Well, it's
fact
been
is
a long
that I've
time
got
for
a
me.
little bit of a dip in my higher frequency hearing, and I'm convinced it's because I play with a wall of violinists.
Oh my
We have a
goodness.
jam session. We have like 9 fiddles going at once. It's like, oh,
I've
no
wondered
wonder I'm
about
hard
that.
of hearing.
I've wondered about that. You normally associate musician hearing damage with rock music, but I once sat on an orchestra stage when they were playing, and those guys must have a risk of their hearing too.
Yeah, it can be pretty loud.
It can be pretty loud.
Yeah.
It's a full orchestra playing Brahms' First Symphony, and it got pretty loud. I don't know if I remember seeing anybody wearing
I
earplugs
haven't heard
though.
of anyone using earplugs in orchestra.
No.
We certainly never did.
Even in the audience, it can get loud at certain times, or a large orchestra in some pieces.
Depending on the music hall.
Yeah. Oh, the best ones that also have pipe organs.
Yeah, our
Oh my God.
local our local hall. It's going to be interesting to see what they do to it. This is the Hopkins Center at Dartmouth. It's
Uh,
actually what sort of the prototype of Lincoln Center.
yeah, went to Lincoln Center many times when I lived in New Jersey.
Yeah, but it was if you look at Hopkins Center, you see the arches, same arches of Lincoln Center was essentially the
Oh,
prototype architecture.
oh, you mean the architecture of the building? I thought you were talking about
Architecture
the
wise,
design of
and
the
then
acoustics of
the
the hall.
hall, the music hall was designed not for voice but for orchestra. So
Yeah.
when you had a performance in it, it was vocal performance. It was a bit dicey, but had a lot of panels in it to bounce
Yeah.
sound around.
I
And
remember when I used to go to concerts in Lincoln Center a lot, Avery Fisher Hall in mid '80s when I lived in
right,
Birch, New Jersey. And I remember the ceiling being covered with these curved wooden panels.
yep,
There were also
these are,
microphones hanging down. I don't know if they were for recordings or actually whether they were there for reinforcement. If it was for reinforcement, it was very subtle.
yeah, they're definitely, yeah, reinforcement.
Most of the concerts I was listening to were Mozart classical concerts, and the orchestra is smaller than you would have for, some of the later composers. It wasn't a full orchestra, but they can still get pretty loud.
So anyway, they're redoing the whole building, and as I understand, they're going to redo the acoustics. Be interesting to see what they come up with.
I know classical music concert goers love to argue about acoustics. It seems like nobody's ever happy with the acoustics in any concert hall, no matter how much money they spend on it.
What drives me nuts is the classrooms now have a lot of DSP in them, and you see the guy's mouth moving, and then you hear it.
Oh, yeah.
Digital processing drives me nuts.
Well, I occasionally say to people that, there's one big Faustian bargain in digital signal processing, and it's latency.
Right.
Everything else we get comes at the cost of latency, and there's no way around it. It's theory.
Now you can simulate analog processing with IIR filters.
Yes, but it won't be
That's not how they do it.
I know, but it won't be the same. Right. I mean, you can't do, yeah, you're going to have the same imperfections or many of the same imperfections as analog filters.
Yeah. Well, the one thing you
Transient
can do is
responses.
create a whole bunch of very accurate filters.
Yeah.
But
Yeah.
to do the same thing as you would with an FIR, it takes a lot more.
That's right. Well, and you're going to introduce a lot of latency too.
Well, not if you do an IIR. That's the whole point.
Well, no, I mean, any filter, no matter what it is, it's got to be causal.
Yeah, well, but an analog filter is an IIR. But there's always a
you
little
can
bit
build
of
an analog
latency.
FIR. It's not often done, but you could.
No, but what I'm saying is when you use L's and C's and whatnot,
Yeah.
that's what an IIR filter is emulating. And you're not going to have a whole lot of latency in that. It comes through pretty quickly.
Well, that's inherent in the structure of the filter. I mean,
right.
It's got a small number of poles and zeros.
If you did the audio processing with IIRs instead of FIRs, you'd have a lot less latency.
But you couldn't get an FIR response if you wanted one.
Mm-hmm.
It's the phase response it's going to be minimum phase, not linear phase.
Right.
But minimum phase means minimum latency. So.
And then, of course, when they were doing up the television standards, they paid no attention to keeping the audio and the video synchronized.
Yeah.
So even to this day, they've gotten better with it, but to this day, there's a lot of stuff that you see the lips move and then you hear it a fraction of a second later.
Oh, you mean with digital TV? Yeah.
Digital
well,
TV.
It's supposed to be. I mean, there are timestamps in each stream, and they're supposed to be used by
Not
the decoders.
really. No, this is my other hat. I've been a member of the Audio Engineering Society, and we had long workshops on what could be done about this.
Which
it was not designed into the original spec to be able to keep them properly synchronized.
I thought it was part of MPEG.
Well, whatever they did,
there was the playout time for each of the components in a stream. No,
right. Well, the components all come through at different times and then get reassembled, and they did not put enough synchronization in there to keep them together.
Sure, but I mean, in the media, in the multiplexed digital stream, there are timestamps that are supposed to allow you to do this. You just have to tune at the ends to
Yeah, well,
take care of any fixed delays. But sure,
yeah, well, they didn't get it quite right. So the TV, when you
yeah,
watch it on a TV set, it comes out of sync.
sometimes. Actually, you can tolerate a fair amount of that. I know there are specs, and it's not linear. You can tolerate errors in one direction more than the other. I forget
Well,
which.
that's the thing is your ear, we expect to see it before we hear it.
That's right.
And the brain doesn't freak out when that happens, but do it the
Right.
other way around.
Yeah. You hear it before you see it. Yeah, that is, yes, yes. Well, I'm often listening to WWV through my receiver while looking at the clock on my laptop just as a gross check on latency.
Yeah.
I do it all the time. And normally I can't even notice it, but because that's probably because the audio is following the video.
Right.
You know, the laptop is synced to NTP, so it's going to be right on while the audio is going to be a little bit delayed. Or a lot, depending on how much play up delay I've added in my monitor program, especially since I'm usually listening over Wi-Fi. Wi-Fi has a lot of retransmissions and misorderings. I assume it's because it has link level transmissions. I haven't really dug into the Wi-Fi protocols. I mean, that used to be, in ham packet, that was my thing, is low level protocols. But I assumed it's a similar reason in Wi-Fi. I can't think of any other reason that packets would arrive out of sequence. But I had to handle that PCM record with Opus because Opus is a stateful codec. And that was actually the biggest hassle in writing OGG Opus streams from a RTP multicast stream was in reordering the packets whenever they would come out of order.
I can imagine.
Yeah, I ended up basically building a big circular queue, I think 64 entries, and then you use the sequence number as a modulo pointer to write into the queue, and then you have a read pointer, and um, you try to send as many as you can until the thing fills up, and then you send an erasure and empty the whole thing at once.
Yeah.
So I learned a lot about containers, at least the OGG container when I was doing this. So I noticed that in the OGG container, they have things called a granule number, which is a very fine resolution timestamp that is supposed to be used to synchronize all the streams that make up a program.
Huh.
It's 64 bits. But it can get complicated because the numbers are actually interpreted differently by the different codecs. So for audio, that number is supposed to be a sample number at whatever sample rate you're using. For video, it's typically a frame number. So the frame rate is much lower than the audio sample rate. But in principle, if you know the rates for both, then you're supposed to still be able to get them perfectly synchronized.
Yeah.
I haven't looked at MPEG, but I always thought MPEG had the same thing. Or a timestamp in each stream and allowed you to put them together.
Well, guys, I have some stuff that I have to do with my family about now, so
Okay.
I can leave it on. Do you want me to shut off the recording?
Yeah, shut off the recording. I'll just
Okay.
mute the microphone.